ಕೆಮಿಕಲ್ ಬಾಂಡಿಂಗ್ ಇಸ್ ಅ ವೆರಿ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್ ಚಾಪ್ಟರ್. ಯಾಕಂದ್ರೆ ನಮ್ಮ KCET ಅಲ್ಲಿ ವಿ ಕ್ಯಾನ್ ಎಕ್ಸ್ಪೆಕ್ಟ್ 2 ಕ್ವಶನ್ಸ್. ಇಫ್ ಯು ಆರ್ ಹ್ಯಾವಿಂಗ್ ಎ ಲಕ್ ಇನ್ನೂ ಜಾಸ್ತಿ ಕ್ವಶನ್ಸ್ ಎಕ್ಸ್ಪೆಕ್ಟ್ ಮಾಡಬಹುದು. ವಿಚ್ ಆಫ್ ದ ಫಾಲೋಯಿಂಗ್ ರಿಪ್ರೆಸೆಂಟ್ ದ ಲೂಯಿಸ್ ಸ್ಟ್ರಕ್ಚರ್ ಆಫ್ ದ N2 ಮಾಲಿಕ್ಯೂಲ್? ದ ಹೈಡ್ರೋಜನ್ ಇಸ್ ಅಟ್ಯಾಚ್ಡ್ ವಿತ್ ದ ಮೋರ್ ಎಲೆಕ್ಟ್ರೋನೆಗೆಟಿವ್. ಹೈಡ್ರೋಜನ್ ಮೇಲೆ ಜಾಸ್ತಿ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಇರುತ್ತೆ, ಜಾಸ್ತಿ ಸ್ಟ್ರಾಂಗ್ ಫಾರ್ಮ್ ಆಗುತ್ತೆ. ನಿಮಗೆ ಒಂದು ಟ್ರಿಕ್ ಕೊಡ್ತೀನಿ. Now, if you follow that one, you will never and ever make bond order questions wrong. Hello, my dear friends. Elrigu namaskara. Myself, Kodam Naveen Kumar, ನಿಮ್ಮ chemistry faculty. I welcome back you all to this incredible platform, Physics Wallah. ಈಗ ನಾನು ಇವತ್ತೇ ನಿಮ್ಮ ಮುಂದೆ ಬಂದಿದ್ದೀನಿ with the another KCET Super 30 series of chemical bonding and the molecular structure. ಈಗ chemical bonding is a very very important chapter. ಯಾಕಂದ್ರೆ ನಮ್ಮ KCET ಅಲ್ಲಿ we can expect 2 questions. If you are having a luck ಇನ್ನೂ ಜಾಸ್ತಿ ಕ್ವಶನ್ಸ್ ಎಕ್ಸ್ಪೆಕ್ಟ್ ಮಾಡಬಹುದು. ಕ್ಲಿಯರ್ ಆಯ್ತಲ್ವಾ? ಮೊದಲನ ಈಗ ನಾನು ಕ್ವಶನ್ ನ ಡಿಸ್ಪ್ಲೇ ಮಾಡ್ತೀನಲ್ವಾ, ಆವಾಗ ನೀವು ಏನ್ ಮಾಡಿ ಅಂದ್ರೆ ಮೊದಲನ ಟ್ರೈ ಯುವರ್ ಸೆಲ್ಫ್. ಓಕೆ, ದೆನ್ ಚೆಕ್ ವೆದರ್ ದ ಆನ್ಸರ್ ಇಸ್ ಕರೆಕ್ಟ್ ಆರ್ ನಾಟ್. ಆಮೇಲೆ ಐ ವಿಲ್ ಸೇ ದ ಟ್ರಿಕ್ಸ್ ಹೌ ಫಾಸ್ಟ್ ದಿಸ್ ಕ್ವಶನ್ಸ್ ಟು ಬಿ ಸಾಲ್ವ್. ಕ್ಲಿಯರ್? ಮೊದಲನ ನೀವು ಏನ್ ಮಾಡಿ ಅಂದ್ರೆ ಫಸ್ಟ್ ಟ್ರೈ ಯುವರ್ ಸೆಲ್ಫ್, ಆಮೇಲೆ ಐ ವಿಲ್ ಸೇ ದ ಟ್ರಿಕ್ ಹೌ ಫಾಸ್ಟ್ಲಿ ಯು ಕ್ಯಾನ್ ಸಾಲ್ವ್ ದಿಸ್ ಟೈಪ್ ಆಫ್ ದ ಕ್ವಶನ್ಸ್. ಈಗ ಕೆಮಿಕಲ್ ಬಾಂಡಿಂಗ್ ಅಲ್ಲಿ ಆಫ್ಟರ್ ಕಂಪ್ಲೀಷನ್ ಆಫ್ ದಿಸ್ ಸಿರೀಸ್ ಆರ್ ವಿಡಿಯೋ, ಈಗ ಕೆಮಿಕಲ್ ಬಾಂಡಿಂಗ್ ಅಲ್ಲಿ ಯಾವ ತರ ಕ್ವಶನ್ ನ ಗೆಲ್ರಿ ಬೈ ಯೂಸಿಂಗ್ ದಿಸ್ ಟ್ರಿಕ್ಸ್ ವಿತ್ ಇನ್ ದ ಸೆಕೆಂಡ್ಸ್ ಆರ್ ವಿತ್ ಇನ್ ದ 5 to 10 seconds you can solve the answer. Okay, ಸರಿ. Now let's start our first question. Now first question any? Now which of the following represent the Lewis structure of the N2 molecule? Lewis dot structure of the N2 molecule ಅಂತ ಕೇಳ್ತಾ ಇದ್ರಲ್ವಾ. ನಾವು ಮೊದಲ ಫಸ್ಟ್ N, this is the N. Now clear? Now ಇನ್ನೊಂದೇನು? Now one nitrogen contain how many valence electron? 5 valence electrons ಅಲ್ವಾ? 5 valence electrons. Clear? Now nitrogen contains 5 valence electrons. Done? Now ಈಗ this nitrogen, ಈಗ ಈ nitrogen ಗೆ ಆಕ್ಟೇಟ್ ಕಂಪ್ಲೀಟ್ ಮಾಡೋಕೆ ಈಗ ಈ nitrogen ಗೆ ಎಷ್ಟು ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಬೇಕು? 3 ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಬೇಕಲ್ವಾ? Now by taking 1 electron here, by taking 1 electron here, by taking 1 electron here. Now this nitrogen octet has been completed. ಈಗ ಈ nitrogen ನ octet has been completed. Clear? Now this is the Lewis dot structure of the N2 molecule. Now ಇದನ್ನ ನೋಡಿ, which structure is matching with this one? Now first one, option A. Now this is blunder, this is also blunder. Now nitrogen, this is also blunder. Now option A is the correct. Clear? Now next question ನೋಡಿ. Now hydrogen bonding is strongest in. ಈಗ hydrogen bonding strongest ಅಂದ್ರೆ hydrogen should have more positive charge, ಜಾಸ್ತಿ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಇರಬೇಕು. ಹೈಡ್ರೋಜನ್ ಗೆ ಯಾವಾಗ ಜಾಸ್ತಿ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಇರುತ್ತೆ? ಹೈಡ್ರೋಜನ್ ಗೆ ಯಾವಾಗ ಜಾಸ್ತಿ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಇರುತ್ತೆ? when the hydrogen is attached with this one, FON. when the hydrogen is attached with the fluorine, ಯಾಕೆ? fluorine is the more electronegative group ಅಲ್ವಾ? ಅಂದ್ರೆ when the hydrogen is attached to the fluorine, now hydrogen is having the more positive charge ಅಂದ್ರೆ more strongly it can attract, more strongly it can form a bond. now ಇದ್ರಲ್ಲ ನೋಡಿ, ನಾವು ಇದರಲ್ಲಿ hydrogen as attached to the sulfur, here oxygen, here the fluorine, ಅಂದ್ರೆ this is having the more positive charge here, more strongly it can form the hydrogen bonding. ಅಂದ್ರೆ HF, ಇನ್ನೊಂದು HF, ಇದರಲ್ಲಿ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್, ಇದರಲ್ಲಿ ನೆಗೆಟಿವ್ ಚಾರ್ಜ್, ಇದರಲ್ಲಿ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್, ಇದರಲ್ಲಿ ನೆಗೆಟಿವ್ ಚಾರ್ಜ್. ನೌ ದಿಸ್ ಇಸ್ ದ ಹೈಡ್ರೋಜನ್ ಬಾಂಡಿಂಗ್. ಕ್ಲಿಯರ್? ಇದನ್ನ ನೆನ್ಪಿಟ್ಕೊಳ್ಳಿ. ಇಫ್ ದ ಹೈಡ್ರೋಜನ್ ಈಸ್ ಅಟ್ಯಾಚ್ಡ್ ವಿತ್ ದ ಮೋರ್ ಎಲೆಕ್ಟ್ರೋನೆಗೆಟಿವ್, ಹೈಡ್ರೋಜನ್ ಮೇಲೆ ಜಾಸ್ತಿ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಇರುತ್ತೆ, ಜಾಸ್ತಿ ಸ್ಟ್ರಾಂಗ್ ಫಾರ್ಮ್ ಆಗುತ್ತೆ. ಕ್ಲಿಯರ್? ನೆಕ್ಸ್ಟ್ ನೋಡಿ, ವಿಚ್ ಆಫ್ ದ ಫಾಲೋಯಿಂಗ್ ಇಸ್ ಹ್ಯಾಸ್ ಹೈಯೆಸ್ಟ್ ಬಾಂಡ್ ಆರ್ಡರ್? ಹೈಯೆಸ್ಟ್ ಬಾಂಡ್ ಆರ್ಡರ್ ಅಂತ ಕೇಳಿದ್ರಂದ್ರೆ ಒಂದೇ ಒಂದು ನೆನ್ಪಿಟ್ಕೊಳ್ಳೋಣ. ಈಗ ನಾನು ನಿಮ್ಗೆ ಒಂದು ಟ್ರಿಕ್ ಕೊಡ್ತೀನಿ. ನಾವು ಇಫ್ ಯು ಫಾಲೋ ದಟ್ ಒನ್ ಯು ವಿಲ್ ನೆವರ್ ಅಂಡ್ ಎವರ್ ಮೇಕ್ ಬಾಂಡ್ ಆರ್ಡರ್ ಕ್ವಶನ್ಸ್ ರಾಂಗ್. ಕ್ಲಿಯರ್? ನೆಕ್ಸ್ಟ್ ಇಲ್ಲಿ ನೋಡಿ, ಫಸ್ಟ್ ನಂಬರ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್. ಫಸ್ಟ್ ಇಸ್ ದ ನಂಬರ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್, ನೆಕ್ಸ್ಟ್ ಬಾಂಡ್ ಆರ್ಡರ್. ಕ್ಲಿಯರ್? ಈಗ number of electrons 1 ಅಂದ್ರೆ bond order is 0.5. If the number of electrons are 2, bond order is 1. If the number of electrons are 3, bond order is 0.5. If the number of electrons are 4, bond order is 1. If the number of electrons are 5, bond order is 0.5. If the number of electrons are 6, bond order is 1. If the number of electrons are 7, bond order is 0.5. If the number of electrons are 8, bond order is 1. Clear? Up to 8 electrons. Up to 8 electrons, this is the bond order. ಈಗ 8 electrons ಇಂದ ಏನ್ ಮಾಡ್ರಿ ಅಂದ್ರೆ ನಾವು number of electrons or else you'll take ಈಗ up to 8 electron, sorry, now 8 electron bond order is 0, sorry. Clear? Now ಈಗ 9, 10, 11, 12, 13, 14. Now 8 ಇಂದ 9 to 14 ಏನ್ ಮಾಡ್ರಿ ಅಂದ್ರೆ increase the 0.5 bond order, increase the 0.5. 9 ಗೆ 0.5, 10 1, 11 1.5, 12 2, 13 2.5, 14 3, 14 3. ಈಗ 14 ಇಂದ up to 19, 15 electron, 16, 17, 18, 19. Clear? ಇದನ್ನ number of electrons. Clear? Now up to 19 electrons ಈಗ ಏನ್ ಮಾಡ್ರಿ ಅಂದ್ರೆ decrease the 0.5, ಇದರಲ್ಲಿ 2.5, ಇದರಲ್ಲಿ 2, ಇದರಲ್ಲಿ 1.5, ಇದರಲ್ಲಿ 1, ಇದರಲ್ಲಿ 0.5. Now this trick is applicable up to 20 electron species only. Up to 20 electrons only. Up to 20 electron. ಈಗ ಇದರಲ್ಲಿ options ಅಲ್ಲಿ if it is having up to 20 electrons only, this bond order will be applicable. Clear? Now ಇದರಲ್ಲಿ ನೋಡಿ ನೈಟ್ರೋಜನ್ ಗೆ ಎಷ್ಟು ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇರುತ್ತೆ? ಅಟಾಮಿಕ್ ನಂಬರ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ನಂಬರ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್. ಅಟಾಮಿಕ್ ನಂಬರ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ನಂಬರ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್. ಕ್ಲಿಯರ್ ಆಯ್ತಲ್ವಾ? ಒಂದು ನೈಟ್ರೋಜನ್ ಅಲ್ಲಿ ಎಷ್ಟು ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇರುತ್ತೆ? ಅಟಾಮಿಕ್ ನಂಬರ್ ಆಫ್ ನೈಟ್ರೋಜನ್ ಇಸ್ 7. ಅಂದ್ರೆ ನೈಟ್ರೋಜನ್ ಅಲ್ಲಿ 7 ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇರುತ್ತೆ. ಎರಡು ನೈಟ್ರೋಜನ್ಸ್ ಅಂದ್ರೆ 14 ಎಲೆಕ್ಟ್ರಾನ್ಸ್. ಇದರಲ್ಲಿ 14 ಎಲೆಕ್ಟ್ರಾನ್ಸ್, ಇದರಲ್ಲಿ 16, ಇದರಲ್ಲಿ 4, ಇದರಲ್ಲಿ 2. ಕ್ಲಿಯರ್? ನಾವು ಇದರಲ್ಲಿ ನೋಡಿ 14 ಎಲೆಕ್ಟ್ರಾನ್ ಬಾಂಡ್ ಆರ್ಡರ್ ಎಷ್ಟು? 3. Now 16 electron bond order ಎಷ್ಟು? 2. 4 electron bond order ಎಷ್ಟು? Sorry, this is 0. Sorry. 4 electron 0. Now 4 electron bond order ಎಷ್ಟು? 0. Now He2 bond order ಎಷ್ಟು? Sorry, He2 bond order is 0. H2 bond order is 1. Sorry, this is 0. Now 4 and the 8 electrons bond order is 0. ಯಾಕಂದ್ರೆ that's the reason helium will not exist as the He2. Helium will exist as the He only. In the nature, He2 will not be exist. ಯಾಕಂದ್ರೆ its bond order is 0. Its bond order is 0. Now Be2, beryllium 2 also will not exist as a Be2. ಯಾಕಂದ್ರೆ its bond order is 0. Bond order is 0. Clear ಆಯ್ತಲ್ವಾ? ಈಗ if you remember this bond order, you can predict the answer very fastly. Now, which of the following is having the highest bond order? A. Next question. Which of the following is, actually the question is not diamagnetic. Question is not diamagnetic. Clear? Now diamagnetic species. How to find out the diamagnetic species? How to find out the diamagnetic species andre up to 14 electrons. Up to 14 electrons, one energy order irutalva. What is that? Sigma 1s, sigma star 1s, next sigma 2s, next sigma star 2s, next pi 2py is equal to pi 2px. Now sigma 2pz, next pi star 2py, next pi star 2px, next sigma star 2pz. This is up to 14 electron. ಈಗ above 14 electron ಗೆ above 14 electron sigma 1s, sigma star 1s, now sigma 2s, next sigma star 2s, next ಒಂದೇ ಒಂದು ಚೇಂಜ್ ಇದರಲ್ಲಿ sigma 2pz, next pi 2py is equal to pi 2px, next pi star 2py, next pi star 2px, next sigma star 2pz. Now this is the energy order. Now ಡಯಾಮ್ಯಾಗ್ನೆಟಿಕ್. He2 ಪ್ಲಸ್ ಅಂದ್ರೆ He2 ಅಲ್ಲಿ 2 ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇರುತ್ತೆ, ಪ್ಲಸ್ ಅಂದ್ರೆ 1 ಎಲೆಕ್ಟ್ರಾನ್. O2 ಅಲ್ಲಿ 16 ಎಲೆಕ್ಟ್ರಾನ್ಸ್. ನಾವು ಲಿಥಿಯಂ ಪ್ಲಸ್ 2 ಅಲ್ಲಿ 6 ಎಲೆಕ್ಟ್ರಾನ್ಸ್. ನಾವು He2 ಪ್ಲಸ್ ಅಂದ್ರೆ 3 ಎಲೆಕ್ಟ್ರಾನ್ಸ್. ನಾವು ಆಲ್ He2, H2 plus, lithium 2 and He2 plus, this 3, 1, 2, 3 will follow this energy order. Now O2 will follow this energy order alva. Now idರಲ್ಲಿ ನೋಡ್ರಿ, ಈಗ He2 plus ಅಂದ್ರೆ 1 electron, ಇದರಲ್ಲಿ 1 electron. Now this is a which of the following is diamagnetic? Oh sorry, correct, question is correct only, sorry. Which of the following is diamagnetic? Clear? Now He2 is a para. Clear? Next O2 16 electron fill ಮಾಡಬೇಕಲ್ವಾ? 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 ಅಂದ್ರೆ this is also para. Now lithium plus 2 ಮೊದಲ ಫಸ್ಟ್ we'll see helium plus 2 ಅಂದ್ರೆ 3 electrons ಅಲ್ವಾ, 1 2 3. helium plus 2 is also para. Which of the following is correct, sorry, which of the following is diamagnetic alva? No, lithium plus 2 andre 6 electrons, 1 2 3 4. This is a lithium 2. Now this is a diamagnetic. Clear? Now in this manner you can predict the answer. Next, number of antibonding electrons pairs in O2 minus 2. The O2 minus 2 ಅಲ್ಲಿ ಆಂಟಿಬಾಂಡಿಂಗ್ ಅಲ್ಲಿ ಎಷ್ಟು ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಪೇರ್ ಇಸ್ ಪ್ರೆಸೆಂಟ್ ಅಂತ ಕೇಳ್ತಾ ಇದ್ರಲ್ವಾ. ನಾವು ದಿಸ್ ಇಸ್ O2 minus 2. O2 contain 16 electrons. minus 2 ಅಂದ್ರೆ 2 electrons added ಅಲ್ವಾ, ಟೋಟಲ್ 18 electrons. ಇದರಲ್ಲಿ ನೋಡಿ, ನಾವು ಅಪ್ ಟು 16 electron we filled for the ಯಾವುದು ಫಾರ್ ದ O2. ಈಗ O2 minus 2 ಅಂದ್ರೆ ಇನ್ನೊಂದು 2 electrons it will be filled here. ನಾವು ಇದರಲ್ಲಿ ನೋಡಿ, this is bonding, this is antibonding ಅಲ್ವಾ. antibonding ಅಲ್ಲಿ ಎಷ್ಟು electron pair ಇದೆ? ಒಂದು 1 electron pair and 2 is second electron pair. Means in the antibonding we are having the 2 electron pair. Clear? Next, now the number of nodal planes present in the sigma star s antibonding orbital. Now sigma star s antibonding electron. Now this is a 1s. Now this is a another 1s. Now this is the nucleus. Now if these two are overlapping with the opposite phase, these two are not the charges. No, these are not the charges. These are the representation of the wave, representation of the sign of the wave, whether it is in the positive loop. Now wave. Now this is a wave alva. Now this is in the positive phase and this is in the negative phase. Now these two are not the charges. Clear? Now when these two are overlapping, now its electron cloud will be distributed. Electron cloud will be distributed from the nucleus. Clear? Now this is the node. This is the node for the sigma star 1s. This is the node for the sigma star 1s. How many nodes? One node will be present for the sigma star 1s. Clear? Now when the two are overlapping with the same phase, now the orbital energy will be, now the electron cloud will be in this manner. Now this is the nucleus. Now here the electron cloud will be over. Now this is a sigma 1s. This is a sigma star 1s and this is a sigma 1s. This is a bonding molecular orbital. Now this is a antibonding molecular orbital. Clear? Next, the overlapping of the orbitals in the benzene is the type of. Overlapping of the orbital in the benzene in the type of. Overlapping of the orbitals in benzene is of type. It is of the PP. It is of the PP. ಯಾಕಂದ್ರೆ ಇದರಲ್ಲಿ ನೋಡಿ ಬೆಂಜಿನಲ್ಲಿ now hybridization of this carbon. Now hybridization of this carbon ಏನು? Hybridization is equal to number of sigma bonds plus lone pairs ಅಲ್ವಾ? Lone pairs. ಇದರಲ್ಲಿ hybridization of this carbon ಎಷ್ಟು? sp2. All the carbons hybridization is sp2 ಅಲ್ವಾ? No. sp2 means ground state electronic configuration of the carbon ಎಷ್ಟು? 1s2, or else we'll take directly 2s2, 2p2. This is the ground state electronic configuration of the carbon alwa. Now excited state electronic configuration. Now one electron in the 2s will be excited to the 2p. 1 2 3 4. Now sp2 means how many orbitals will be overlapped? 3 orbitals will be overlapped alwa. So 3 orbitals will be overlapped to give the new sp2 hybridized orbital. New sp2 hybridized orbitals like this. And we are having the one pure p orbital. Now we are having the one pure p orbital. Now pure p orbital. Now this pure p orbital, the overlapping of the orbitals in the benzene is of the pp due to the pure p orbital. Empty pure p orbital. This is the pure p orbital. With this pure p orbital, the overlapping of the benzene is pp type. Clear? Next. Now calculate the bond order of the superoxide of the O2 minus. O2 minus ಅಂದ್ರೆ O2 ಅಲ್ಲಿ ಎಷ್ಟು ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇರುತ್ತೆ? 16. ಅಂದ್ರೆ -1 ಅಂದ್ರೆ 17 electrons. ಈಗ 17 electrons ಗೆ ಬಾಂಡ್ ಆರ್ಡರ್ ಎಷ್ಟು? Here I given ಅಲ್ವಾ? Now 17 electrons, the bond order will be 1.5. The answer is 1.5. ಈಗ if the trick is problematic for you, now formula ಏನು bond order is equal to half number of bonding electrons minus number of antibonding electrons ಅಲ್ವಾ? Number of bonding electrons minus number of antibonding electrons. O2 minus 2 ಅಲ್ಲಿ number of bonding electrons ಎಷ್ಟು? ಇದರಲ್ಲಿ ನೋಡಿ. Now this is for this we have this ಇದು ಯಾವುದು for which one? O2 minus 2 ಅಲ್ವಾ? O2 minus 2 ಅಂದ್ರೆ if you want O2 minus ಗೆ ಒಂದು electron have to erase ಅಲ್ವಾ ಇದರಲ್ಲಿ? If I remove this one electron, here, now if I remove one electron here, now number of bonding electrons is to 2, 4 plus 4, total how much? 2, 4, 6, 8, 10. Total number of bonding electrons in O2 minus ಎಷ್ಟು? ಟೋಟಲ್ 2, 4 ಮತ್ತೆ 6, 8, 10. ಟೋಟಲ್ 10. ಆಂಟಿಬಾಂಡಿಂಗ್ ಎಷ್ಟು? 2, 4, 5. Total number of bonding electrons are 10. Antibonding electrons are 5. Clear? Oh, somewhere it has gone. Okay, better. We'll draw the structure of the O2 minus. Now this is sigma 1s, sigma star 1s, next sigma 2s, next sigma star 2s, next sigma 2pz. Next pi 2py is equal to pi 2px. Next pi star 2py. Next pi star 2px. Next sigma star 2pz. Clear? Now 17 electrons alwa. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Clear? Now we'll run nodi. Number of bond order is equal to half number of bonding electrons minus number of antibonding electrons alva. 2, 4, total 2, 4, 6, 8 and the 10. Antibonding 2, 4, 4, 5, 6, 7. 5, 6, 7. Antibonding electrons are 7 and half. It will be equal to 3 by 2. 3 by 2 will be 1.5. 1.5. Clear? Now, next, among the following compound that contains ionic, covalent and the coordinate bond. Clear? Now, he is asking him among the following which is having all the 4 types of the bonds. All the 4 types of the bonds. Now, first NH4Cl takoni. NH4Cl. Now, NH4Cl. Now, how it will be dissociated? NH4 plus Cl minus alva. Cl minus. Clear? Now, the bond between NH4Cl alli ionic bond is present. Next NH4Cl. How to write? Now, this is NH4. Now, this is the NH4 plus. This is the NH4 ammonium ion. Now, this is the ammonium ion. Clear? Now, idರಲ್ಲಿ ನೋಡಿ bond between this nitrogen and the hydrogen. Now, this bond we call it as a coordinate covalent bond. This bond we call it as a coordinate covalent bond. Now, idರಲ್ಲಿ ನೋಡಿ nitrogen ಮತ್ತೆ hydrogen. Now, the bond between these is a covalent bond. Now, this is a covalent bond. Now, this is a dative bond. Dative bond or coordinate covalent bond. Now, NH4Cl. Now, even though the compound is ionic, it contain covalent as well as a dative bond. Now, answer is A. Now, NaCl tagondidandre only it can be split into Na plus and the Cl minus. It is ionic only. Now, calcium oxide also same. Now, NH3 anta tagolindre andre NH3 also the bond between nitrogen and the hydrogen is covalent. Now, by sharing of this ammonia, this is the ammonia alva. Now, ammonia ge one lone pair irutalva. Now, this lone pair has been given to the electron deficient species. Now, this nitrogen electrons will be given to the electron deficient species in the form of a coordinate covalent bond. Andre e electron na this nitrogen electrons will be between these two. Adigoskaraನೆ this bond na enantare coordinate covalent bond antare. Clear? Now, in NH4Cl all 3 we are having. Clear? Next question. Next question yadu? A covalent molecule AB3 has pyramidal structure. The number of lone pair and bond pair electrons in the molecule are respectively. Clear? Now, ಒಂದು A, B, and it is having one lone pair of electrons. How many bond pair? 1, 2, 3, and one lone pair. Means one bond pair, one lone pair, and the 3 bond pair. Example ammonia. Clear? Okay, covalent molecule AB3 has pyramidal structure. Ammonia is having the pyramidal structure alva. Now, number of lone pair and the bond pair. One lone pair and the 3 bond pair in the molecules are respectively. Pyramidal structure is having the pyramidal structure is having the 1 lone pair and the 3 bond pairs. Clear? Next, correct statement with regard H2 plus and the H2 minus. Clear? H2 plus H2 minus. Now, energy order barri. Sigma 1s, next sigma star 1s, next sigma 2s. But idralli ಎಷ್ಟು electrons? 1 electrons. Idralli ಎಷ್ಟು electrons? 3 electrons. Clear? Now, sigma 1s, next sigma star 1s. Sigma star 1s. Clear? Now, sigma H2 plus andre 1 electron. H2 minus andre 3 electrons alva? No. Clear? No. If the electron is present in antibonding, iga electron antibonding alli idi andre, now that species is compared to this one, this is less stable. Yakandre electron is present in the antibonding. Energy of the antibonding is higher than the bonding. Adigoskarané H2 is having the less stable than the H2 plus. H2 minus is less stable than the H2 plus. Idral nodi, option nodi. Both H2 plus and the H2 minus does not exist. Yakandre it will exist. Idral nodi, bond order is 0.5. Idralli bond order is 0.5. Idralli the bond order is also 0.5. Bond order ing find ಮಾಡಬಹುದು half number of bonding electrons minus number of antibonding electrons. Now idralli bonding electrons is to 2, antibonding electrons is to 1 by 2, 0.5. Now idralli nodi, now bonding electrons is to 1, antibonding electrons 0 andre 1 by 2. Idralli no bond order is 0.5. I said right, 1 electron na bond order 0.5, 3 electron na bond order also 0.5. Both H2 plus H2 minus does not exist. This is wrong. Now H2 minus is more stable than the H2 minus is more stable than the H2 plus. Wrong. Yakandre H2 plus alli electron is present in bonding, but H2 minus alli ಒಂದು electron is present in antibonding. ಅದರಲ್ಲಿ ಜಾಸ್ತಿ energy ಇದೆಯಲ್ವಾ antibonding ಗೆ, means that will be less stable. Now H2 plus is more stable than the H2 minus. This is correct. Both H2 plus and the H2 minus are equal. No, H2 plus is more stable than the H2 minus. ಈಗ ಯಾಕಂದ್ರೆ antibonding electrons ಅಲ್ಲಿ electron ಇದೆ ಅಂದ್ರೆ that is least stable. Clear? Now arrange the following increasing order of their bond order. Already ನಾನು ಈಗ ನಿಮಗೆ ಒಂದು ಶಾರ್ಟ್ ಟ್ರಿಕ್ ಕೊಟ್ಟಿದ್ದೀನಲ್ವಾ. ಫಸ್ಟ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಫೈಂಡ್ ಮಾಡಿ. O2 ಅಲ್ಲಿ ಎಷ್ಟು ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇರುತ್ತೆ? 16. O2 ಪ್ಲಸ್ ಅಲ್ಲಿ ಎಷ್ಟು ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇರುತ್ತೆ? 15 ಎಲೆಕ್ಟ್ರಾನ್ಸ್. O2 ಮೈನಸ್ ಅಲ್ಲಿ ಎಷ್ಟು ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇರುತ್ತೆ? 17 ಎಲೆಕ್ಟ್ರಾನ್ಸ್. O2 minus 2 ಅಲ್ಲಿ ಎಷ್ಟು ಎಲೆಕ್ಟ್ರಾನ್ ಇರುತ್ತೆ? 18. Now bond order. Now 16 electron bond order is to 2. 15 electron bond order is to 2.5. 17 electron bond order is to 1.5. 18 electron bond order is to 1. Now arrange the increasing order alva. Now increasing order. First O2 plus. Next O2. Next O2 minus. Alva. O2 minus. Next O2 minus 2. Andre option D. Clear? Now this is the answer. Next. Which one of the following conversion involves change in both hybridization and the shape? Which conversion, both hybridization as well as the shape should be changed? Now idral nodi. First CH4 C2H6. Now CH4. Now C2H6. Now this is a C2. Now this is the C2H6. Sorry. Now this is C2H6. Now first, carbon hybridization, hydrogen. Clear? Now hybridization find ಮಾಡಬಹುದು number of sigma plus number of ಲೋನ್ ಪೇರ್ಸ್ ಅಲ್ವಾ. ನೌ ನಂಬರ್ ಆಫ್ ಸಿಗ್ಮಾ ಬಾಂಡ್ಸ್ ಎಷ್ಟು 4. ಈಗ ಹೈಬ್ರಿಡೈಸೇಷನ್ ನಂಬರ್ 4 ಅಂದ್ರೆ ದಿಸ್ ಈಸ್ sp3. ನಾವು ಇದರಲ್ಲಿ ಕಾರ್ಬನ್ ನಂಬರ್ ಆಫ್ ಸಿಗ್ಮಾ ಬಾಂಡ್ಸ್ 1 2 3 4 ಅಂದ್ರೆ ದಿಸ್ ಕಾರ್ಬನ್ ಹೈಬ್ರಿಡೈಸೇಷನ್ ಆಲ್ಸೋ sp3. ದಿಸ್ ಕಾರ್ಬನ್ ಹೈಬ್ರಿಡೈಸೇಷನ್ ಇಸ್ ಆಲ್ಸೋ sp3. there is no change in hybridization. the first one. second one ನೋಡಿ. second one ಅಲ್ಲಿ ammonia and the ammonium ion NH4 plus. ಕ್ಲಿಯರ್. ಈಗ ಅಮೋನಿಯಾ ಅಲ್ಲಿ ಫಸ್ಟ್ ನೈಟ್ರೋಜನ್ ವ್ಯಾಲೆನ್ಸಿ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಎಷ್ಟು 5 1 2 3 4 5. ನೌ ಹೈಡ್ರೋಜನ್ ವಿಲ್ ಫಾರ್ಮ್ ದ ಸಿಂಗಲ್ ಬಾಂಡ್ ಅಲ್ವಾ 1 2 3 ಅಂದ್ರೆ ದಿಸ್ ಈಸ್ ಎಸ್, ದಿಸ್ ಈಸ್ ಪಿ, ದಿಸ್ ಈಸ್ ಪಿ ಮತ್ತೆ ಇದರ ಪಿ ಅಂದ್ರೆ ದಿಸ್ ಹೈಬ್ರಿಡೈಸೇಷನ್ ಇಸ್ sp3 ವಿತ್ ಒನ್ ಲೋನ್ ಪೇರ್ ನೆಕ್ಸ್ಟ್ ಇದನ್ನ ನೋಡಿ. ನೈಟ್ರೋಜನ್ ವ್ಯಾಲೆನ್ಸಿ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಎಷ್ಟು 5 ಅಲ್ವಾ 1 2 3 4 5 ಬಟ್ ಪ್ಲಸ್ ಅಂದ್ರೆ 1 ಎಲೆಕ್ಟ್ರಾನ್ ಹ್ಯಾಸ್ ಬೀನ್ ಲಾಸ್ಟ್. ಇದರಲ್ಲಿ ಹೈಡ್ರೋಜನ್ಸ್ 1 2 3 4. ಕ್ಲಿಯರ್. ನೌ ದಿಸ್ ಇಸ್ ಅ ಎಸ್, ದಿಸ್ ಇಸ್ ಅ ಪಿ, ದಿಸ್ ಇಸ್ ಅ ಪಿ, ದಿಸ್ ಇಸ್ ಅ ಪಿ ಅಂದ್ರೆ ದಿಸ್ ಇಸ್ sp3. ನೌ ದಿಸ್ ಇಸ್ ಆಲ್ಸೋ sp3. there is no change in the hybridization. Now he is asking involve change in both hybridization as well as the shape. Now F BF3 and BF4 minus. No, BF3. Now boron ಅಲ್ಲಿ ವ್ಯಾಲೆನ್ಸಿ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಎಷ್ಟು ಇರುತ್ತೆ 3. Fluorine will form the single bond alwa. Now this is S, this is P, this is P andre this is sp2. Now BF4 minus ಅಂದ್ರೆ 1 2 3. now minus ಅಂದ್ರೆ 1 electron extra added. now fluorine 4 fluorines alwa. now this is S, this is P, this is P, this is P. ಅದರಲ್ಲಿ ನೋಡಿ this is sp2, this is sp3 ಅಂದ್ರೆ hybridization is change. now trigonal planar to tetrahedral. option number C. now H2O H3O plus both it will give the sp3 only. ಇದನ್ನ ನೋಡಿ. now oxygen valence electrons ಎಷ್ಟು 6 ಅಲ್ವಾ 1 2 3 4 5 6. hydrogen 1 2 andre this is S, this is P, now this is P, now this is also P andre this is sp3 with 2 lone pairs. now O3 minus H3O plus. now oxygen valence electrons ಎಷ್ಟು 6 ಅಲ್ವಾ 1 2 3 4 5 6. ಬಟ್ ಈಗ ಇದರಲ್ಲಿ ಪ್ಲಸ್ ಅಂದ್ರೆ ಒಂದು ಎಲೆಕ್ಟ್ರಾನ್ ಹ್ಯಾಸ್ ಬೀನ್ ಲಾಸ್ಟ್, ಹೈಡ್ರೋಜನ್ ನಾವು ಕೌಂಟ್ ಮಾಡಿ. ಎಸ್ ದಿಸ್ ಇಸ್ ಪಿ, ದಿಸ್ ಇಸ್ ಪಿ ಮತ್ತೆ ಇದನ್ನ ಪಿ. ಬೋತ್ ದ ಹೈಬ್ರಿಡೇಷನ್ಸ್ ಇಸ್ sp3 ಓನ್ಲಿ. ಆಪ್ಷನ್ ಸಿ ಇಸ್ ಕರೆಕ್ಟ್. ನೆಕ್ಸ್ಟ್ when O2 is converted into O plus 2, ಅಂದ್ರೆ ಈಗ O2 when it is converted to the O2 plus, ಇದರಲ್ಲಿ ಬಾಂಡ್ ಆರ್ಡರ್ ಆಫ್ ದ O2 ಎಷ್ಟು? ಬಾಂಡ್ ಆರ್ಡರ್ ಆಫ್ ದ O2 is 2. O2 plus ಅಲ್ಲಿ ಬಾಂಡ್ ಆರ್ಡರ್ ಎಷ್ಟು 2.5. both are the paramagnetic only. now next ಈಗ ನೋಡ್ರಿ, both paramagnetic character and the bond order increase. next ನೋಡಿ, bond order decrease ಇಲ್ಲ. O2 bond order 2 when it is converted into O2 plus bond order has been increases alva 2 in the 2.5. now paramagnetic character increases ಇಲ್ಲ. ಇದರಲ್ಲಿ ಎರಡು ಅನ್ಪೇರ್ಡ್ ಎಲೆಕ್ಟ್ರಾನ್, ಇದರಲ್ಲಿ ಒಂದೇ ಅನ್ಪೇರ್ಡ್ ಎಲೆಕ್ಟ್ರಾನ್. ಪ್ಯಾರಾಮ್ಯಾಗ್ನೆಟಿಕ್ ಡಿಕ್ರೀಸಸ್ ಯಾಕಂದ್ರೆ ಈಗ ಪ್ಯಾರಾಮ್ಯಾಗ್ನೆಟಿಕ್ ಅಂದ್ರೆ mu is directly proportional to the n into n plus 1 ಅಲ್ವಾ. ಈಗ ನಂಬರ್ ಆಫ್ ಅನ್ಪೇರ್ಡ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇನ್ಕ್ರೀಸ್ ಅಂದ್ರೆ paramagnetic character also increases. now next, paramagnetic character decreases and the bond order increases. both paramagnetic character and the bond order increases. ಇಲ್ಲಿಂದ O2 ಇಂದ O2 ಪ್ಲೇಸ್ ಹೋಗಿದಾಗ ಏನಾಯ್ತು, ಪ್ಯಾರಾಮ್ಯಾಗ್ನೆಟಿಕ್ ಕ್ಯಾರೆಕ್ಟರ್ ಡಿಕ್ರೀಸ್ ಆಯ್ತು. ಯಾಕಂದ್ರೆ ಇದರಲ್ಲಿ O2 ಅಲ್ಲಿ ನಾವು pi star 2py equal to pi star 2px. ನಾವು ಇದರಲ್ಲಿ 1 ಅನ್ಪೇರ್ಡ್ ಎಲೆಕ್ಟ್ರಾನ್, ಇದರಲ್ಲಿ 1 ಅನ್ಪೇರ್ಡ್ ಎಲೆಕ್ಟ್ರಾನ್ ಅಲ್ವಾ. ನಾವು ಇದರಲ್ಲಿ 16 ಎಲೆಕ್ಟ್ರಾನ್ಸ್, O2 ಪ್ಲಸ್ ಅಲ್ಲಿ 15 ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಅಲ್ವಾ, ಅಂದ್ರೆ ದಿಸ್ ಎಲೆಕ್ಟ್ರಾನ್ ಹ್ಯಾಸ್ ಬೀನ್ ಲಾಸ್ಟ್. ಪ್ಯಾರಾಮ್ಯಾಗ್ನೆಟಿಕ್ ಕ್ಯಾರೆಕ್ಟರ್ ಡಿಕ್ರೀಸ್ ಆಯ್ತಲ್ವಾ, ಪ್ಯಾರಾಮ್ಯಾಗ್ನೆಟಿಕ್ ಕ್ಯಾರೆಕ್ಟರ್ ಡಿಕ್ರೀಸ್, ಬೋತ್ ದ ಪ್ಯಾರಾಮ್ಯಾಗ್ನೆಟಿಕ್ ಕ್ಯಾರೆಕ್ಟರ್ ಬಾಂಡ್ ಆರ್ಡರ್ ಇಸ್ ಇನ್ಕ್ರೀಸ್ಡ್ ಬಟ್ ಪ್ಯಾರಾಮ್ಯಾಗ್ನೆಟಿಕ್ ಕ್ಯಾರೆಕ್ಟರ್ ಡಿಕ್ರೀಸಸ್, ಅಂದ್ರೆ ಆಪ್ಷನ್ ನಂಬರ್ 1 ಇಸ್ ರಾಂಗ್. ಬಾಂಡ್ ಆರ್ಡರ್ ಇಸ್ ಡಿಕ್ರೀಸ್, ಇಲ್ಲ ಬಾಂಡ್ ಆರ್ಡರ್ ಇನ್ಕ್ರೀಸ್, ಆಪ್ಷನ್ ನಂಬರ್ 2 ಇಸ್ ರಾಂಗ್. Paramagnetic character increase, yes, paramagnetic character increase and the bond order is also increase. Sorry, paramagnetic character decrease, andre this is also wrong. Now, paramagnetic character decrease, yes, paramagnetic character decrease, bond order increase, option number 4. Option number 4. See, ee tara questions kelta idru, you have to be very careful, you have to be very careful. See, iga bond order gottilla andre you cannot predict the answer. Iga energy diagram gottilla andre you cannot predict the diagram, you cannot predict the answer. Clear? Next question. Which one of the following has no unpaired electrons? Which one of the following has no unpaired electrons? Now, we know O2 ಅಲ್ಲಿ 16 electrons, 2 unpaired ಇರುತ್ತೆ, 2 unpaired. Next O2 minus ಅಂದ್ರೆ 17 electrons. 17 electrons ಅಂದ್ರೆ 1 unpaired electron ಇರುತ್ತೆ, 1 unpaired electron ಇರುತ್ತೆ. ನೆಕ್ಸ್ಟ್ O2 ಪ್ಲಸ್ ಅಲ್ಲಿ 1 ಅನ್ಪೇರ್ಡ್ ಇರುತ್ತೆ. O2 ಮೈನಸ್ 2 ಅಲ್ಲಿ 0 ಅನ್ಪೇರ್ಡ್. ಕ್ಲಿಯರ್? ನಾವು ಆಲ್ರೆಡಿ ಈಗ ಇದರಲ್ಲಿ ಎನರ್ಜಿ ಪ್ರೊಫೈಲ್ ಡಯಾಗ್ರಾಮ್ ಇದೆಯಲ್ವಾ, ನೋಡ್ರಿ, ಎನರ್ಜಿ ಪ್ರೊಫೈಲ್ ಡಯಾಗ್ರಾಮ್ ಫಾರ್ ದಿಸ್ 17 electrons 1 ಅನ್ಪೇರ್ಡ್ ಎಲೆಕ್ಟ್ರಾನ್. O2 minus 2 18 electrons ಅಲ್ವಾ, 18 electrons ಅಂದ್ರೆ ಇನ್ನೊಂದು ಎಲೆಕ್ಟ್ರಾನ್ ಆಡ್ ಮಾಡಿದ್ವಿ ಅಂದ್ರೆ 0 ಅನ್ಪೇರ್ಡ್. O2 ಅಂದ್ರೆ if I remove 1 electron ಇಂದ ಇಲ್ಲಿಂದ 1 electron ರಿಮೂವ್ ಮಾಡಿದ್ರೆ ಅಂದ್ರೆ, ಯಾಕಂದ್ರೆ when you are filling the O2 electrons in this molecular orbital energy diagram, you should not fill the 2 electrons in one orbital. ಯಾಕಂದ್ರೆ these two are degenerate orbitals. Degenerate ಅಂದ್ರೆ same energy ಇರುತ್ತೆ. According to the Hund's rule, now electrons to be filled first, then only the pairing will be happened. Now this is a 16. Now 2 unpaired electrons. Next we are having what we are having? Next O2 plus andre if you remove 1 electron in the, we are having 1 unpaired. Clear? O2 minus 2 we are having the 0 unpaired. Now answer is this one. No unpaired anta kelta idra alva. Next intramolecular hydrogen bonding is formed in. Intramolecular ಅಂದ್ರೆ within the molecule bond ಇರಬೇಕು. within the molecule bond ಇರಬೇಕು. Clear? Inter ಅಂದ್ರೆ between two molecules. Clear? Now H2O, this is not forming the intramolecular hydrogen. Now salicylaldehyde. Now this is a salicylaldehyde. Now this is a intramolecular hydrogen bonding is formed in the salicylaldehyde. Next NH3 there is no intramolecular hydrogen. Benzophenone also there is no any intramolecular hydrogen bonding. Only the intramolecular hydrogen bonding is seen in the salicylaldehyde. ಈಗ this salicylaldehyde reaction ಯಾವುದು? Raman-Timmer reaction. ಈಗ ಈ ತರನು ಕ್ವೆಶ್ಚನ್ಸ್ ಬರಿಬಹುದು. what ಈ ತರನು they can ask the questions. how they can ask? now salicylaldehyde ಅಲ್ವಾ. now in the organic how they can ask the same question? now in the product it is having the intramolecular hydrogen bonding. The product it is having the intramolecular hydrogen bonding and its electrophile is to convert this conversion. What is the electrophile anta ಹೇಳ್ತಾ ಇದೆ. Clear? now to salicylaldehyde to convert phenol in the salicylaldehyde to convert ಮಾಡೋಕೆ what is the electrophile we will use? Dichlorocarbon is the electrophile used in this Raman-Timmer reaction. Clear? now this is the intramolecular hydrogen bonding. Hydrogen bonding ಎಲ್ಲಿಂದ ಇರಬೇಕು? within the molecule ಇರಬೇಕು. but H2O it will form the hydrogen bonding, but this will be what? this will be the intermolecular ಅಂದ್ರೆ between two molecules. This is a intermolecular. Ammonia is also will form the intermolecular. Benzophenone also will form the intermolecular. Next, which of the following is diamagnetic? Now, which of the following is diamagnetic? Idralli one electron para. Now He2 plus andre 3 electrons also para. Now O2 16 electrons. Now already nodidvi para. Now next to N2 14 electrons dia. Clear? 14 electrons dia. Next, the number of antibonding electrons present in the O2 minus ಅಲ್ಲಿ number of antibonding electrons ಅಂತ ಕೇಳ್ತಾ ಇದ್ರಲ್ವಾ, number of antibonding electrons ಇದನ್ನ ನೋಡ್ರಿ, number of antibonding electrons the O2 minus ಅಲ್ವಾ, O2 minus ಅಂದ್ರೆ 17, O2 minus ಇದರಲ್ಲಿ ಅಪ್ ಟು 16 ಅಲ್ವಾ, 16 ಈಗ ಒಂದು ಎಲೆಕ್ಟ್ರಾನ್ ಆಡ್ ಮಾಡಿದ್ವಿ ಅಂದ್ರೆ ಟೋಟಲ್ 17. ಟೋಟಲ್ ಆಂಟಿಬಾಂಡಿಂಗ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ 1 2 3 4 5 6 7, total 7 antibonding electrons are present in O2 minus. Now, total how many antibonding electrons? Okay, ಏನಾಯಿತು, 8 6 5 4. Now there is sigma star 1 is 2, next 2 next pi 2py 1 2 4, next pi 2px 1 2 3 4 5 6 7. Number of antibonding electrons present in, actually maybe sorry, this is O2 minus 2, maybe O2 minus 2 molecular ion. O2 minus 2 it should be 7, but option it is there, but question is O2 minus 2 total 8 antibonding electrons, that is O2 minus 2 ಅಲ್ಲಿ number of antibonding electrons total 8. O2 minus ಅಲ್ಲಿ antibonding electrons ಇದೆಲ್ಲ ನೆನಪಿಟ್ಕೊಳ್ಳಿ, antibonding electrons ಇಂದ O2 minus ಅಲ್ಲಿ 7. now O2 ಅಲ್ಲಿ ಎಷ್ಟು 1 2 3 4 5 6, clear? now total bonds 6, 10 bonding, antibonding 6, then it will be the 4 by 2, it will be the bond order will be 2. Next O2 plus antibonding electrons is to 5. Now remove 1 electron and remove 1 electron here and remove 2 electrons, total 5. Clear? now O2 minus 2 8 antibonding andre A, option A is correct. Next, a pair of compounds having identical shape for their molecule. Identical shape ಅಂತ ಕೇಳ್ತಾ ಇದ್ರಲ್ವಾ, CH4 and SF4. Now this is a tetrahedron. SF4 valence electrons ಎಷ್ಟು 6 valency, 4 fluorines. ಅಂದ್ರೆ this is S, this is P, this is P. Now this is D, andre this is sp3d. Now this is sp3, both are not having same shape. Clear? now sp3d with one lone pair, this is a distorted tetrahedron. Next BCl2 1 2 3 Cl andre this is sp2 BCl2, this hybridization now this is S, this is P, this is P, andre this is sp2 ClF3. Now chlorine valence electrons ಎಷ್ಟು 7 alva. 1 2 3 4 5 6 7. 1 fluorine, 2 fluorine, 3 fluorine. 1 2 3. Now this is S, this is P, this is P. Now this is D. This is P. Now this is D. Andre this is also sp3 with D, sp3d with 2 lone pair, with 2 lone pair. This circles ಏನಂದ್ರೆ ಒಂದು ಲೋನ್ ಪೇರ್ ಅಲ್ಲಿ ಎಷ್ಟು ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇರುತ್ತೆ? 2 ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇರುತ್ತಲ್ವಾ? ಒಂದು ಲೋನ್ ಪೇರ್ ಅಲ್ಲಿ 2 ಎಲೆಕ್ಟ್ರಾನ್ಸ್. ಕ್ಲಿಯರ್? sp3d with 2 lone pair, but this is a sp2. Both are not having the same shape. Now xcf2 ZnCl2, xcf2 ZnCl2. Next, first this will see SO2 and the CO2. SO2 sulfur 1 2 3 4 5 6. Oxygen is a bivalent. ಯಾಕಂದ್ರೆ oxygen will form the double bond. Now 2 oxygens. Andre this is S, this is P. Now this is P. Andre this is having the sp2 with 1 lone pair. sp2 with 1 lone pair. Clear? Now sp2 with 1 lone pair. Now this is having the bent shape like this. Bent shape. Now CO2. This is a linear. Now this is having the sp. This is having the sp hybridization linear. Now here the compound having the identical shape and the molecule, that is a xcf2 ZnCl2. xcf2 and the ZnCl2. Now you know. Now Xe, xenon will comes under the noble gases alva. Noble gases ge valence electrons ಎಷ್ಟು ಇರುತ್ತೆ? 8 ಇರುತ್ತೆ. 1 2 3 4 5 6 7 8. Clear? Now ಇದರಲ್ಲಿ ಎಷ್ಟು fluorines? 1 fluorine, 2 fluorine. Andre this is S, this is P. Now this is also P. Now this is also P. Now this is D. Clear? Now this is sp3d. sp3d with 2 lone pair. Now ZnCl2. Now ZnCl2 is also having the Cl, and this is a Cl. Now this is also linear. Now here what is asking? The pair of compounds having the identical shapes, but not asking the hybridization. Identical shapes. Now xcf2 also will be in this manner, and it is having the 3 lone pairs like this. Both are having the linear shape. Clear? Both are having the linear shape. Next, using MOT, compare O2 plus and the O2 minus species. Choose the incorrect. O2 plus O2 minus. Bond order. First bond order 2.5, bond order 1.5. Clear? 1.5. Number of antibonding electrons 5. Number of antibonding electrons 7. Clear? Now see, O2 ಈಗ number of antibonding electrons ಜಾಸ್ತಿ ಅಂದ್ರೆ stability less. Number of antibonding electrons ಕಡಿಮೆ ಅಂದ್ರೆ stability ಜಾಸ್ತಿ. Clear? Now O2 minus is less stable. Which of the following is incorrect? But this is correct. O2 minus is less stable. Yes, compared to the O2 plus, O2 minus is less stable. ಯಾಕಂದ್ರೆ ಜಾಸ್ತಿ antibonding electrons ಇದೆಯಲ್ವಾ? Next, both O2 plus and O2 minus is paramagnetic. Both O2 plus and O2 minus, yes, ಇದರಲ್ಲಿ this is also paramagnetic. O2 minus is also paramagnetic. Next, O2 is having higher bond order than the O2 plus is having the higher bond order than the O2 minus. Now yes, O2 plus is having the bond order 2.5, O2 minus is having the 1.5. This is also correct. ಇದರಲ್ಲಿ ನೋಡಿ O2 plus is diamagnetic, but O2 plus is para alva. Para. Now this is wrong. This is what is asking? Incorrect. Now this is incorrect. O2 plus is diamagnetic while O2 plus is paramagnetic. No, O2 plus is also diamagnetic. Sorry, O2 plus is also paramagnetic. This is the wrong. Next question. HCl gas is covalent and the NaCl is ionic compound. This is because. ಈಗ ನಾನು ನಿಮಗೆ ಒಂದು ಟ್ರಿಕ್ ಕೊಟ್ಟಿದ್ದೀನಲ್ವಾ? How to identify? ಈಗ electronegativity difference, if it is greater than 1.7, ionic. Electronegativity difference, if it is less than 1.7, that is covalent. ಕೋವಲೆಂಟ್. ಕ್ಲಿಯರ್? ನಾವು HCl ಅಂದ್ರೆ ನೋಡ್ರಿ, HCl. Electronegativity value of hydrogen is 2.1. Chlorine electronegativity value is 3. Andre difference ಎಷ್ಟು 0.9. 0.9 is less than the 1.7 alva. 1.7 andre this is a covalent. Now next nodri, now NaCl. NaCl, Na and Cl. Na electronegativity is 0.9. Electronegativity value 3. Now difference is 2.1. Now 2.1 is greater than 1.7 alva. Andre bond between these two is ionic. Bond between these two is ionic. Means electronegativity difference between the hydrogen and the chlorine is less than 2.1. Less than 2.1. Yes, this is having the 0.9. Less than 2. Better we can take the 1.7 or 2.1. Both it will give the correct only. Clear? Now we'll take the 0.9. Now this is electronegativity difference between the hydrogen and the chlorine is less than 2.1. Adugoskarane HCl is covalent, NaCl is ionic. Clear? Now hydrogen is a non-metal, correct. Sodium is a Ia electropositive, HCl is a gas. These all are correct. Now this is the differentiating both. Next, main axis of the diatomic molecule is Z. Internuclear axis is Z. Internuclear axis is Z. Okay. Internuclear axis ge PX is perpendicular. PX is perpendicular. If this is a this is the internuclear axis. This is our internuclear axis. Now PX orbital will be perpendicular to the internuclear axis. Now PY orbital will be like this. Let assume this is our internuclear axis. This pen is our internuclear axis. Now this is a PX bond. Now this is a PY bond. Now this is a PZ. Means for the internuclear axis both are perpendicular only, right? Both are perpendicular only. Now this is PX. Now this is PY. Now towards you. This is towards you alva. This is internuclear axis. One is perpendicular, another is also perpendicular. But this is like you. PX is like this, PY is like this. Overlapping. If these two are sideways overlaps leads to give the pi bond. But here one is in this manner and one is in this manner. These two overlaps leads to give the no bonding, zero overlapping. These two overlapping leads to give the zero overlapping. ಈಗ sideways overlapping PXY and PX sideways overlaps leads to give the pi. Now sigma means here the internuclear axis is Z. Internuclear axis is Z. Okay, internuclear axis in the if these two electrons along the internuclear axis if they are overlap, this leads to give the sigma. Now the delta bond it will be formed between the dxy. Clear? Next. Now which of the following structure of a molecule is expected to have a 3 bond pairs and 1 lone pairs? Now which of the following? Nitro, NH3 ammonia anta tagolli. Now it is having a 3 bonds and as well as a 1 lone pair alva. Now it is having the pyramidal shape. Octahedral ge if you take the SF6, now there is 6 bond. Now tetrahedral tagondidu andre now CH4. Now it is having the 4 bonds. It is having the 4 bond pairs. Trigonal planar BF3. But it is having the 3 bond pairs but 0 lone pairs. But he is asking 1 lone pair as well as the 3 bond pairs. That is present in the pyramidal shape only. Next, intramolecular hydrogen bonding is present. Next, intramolecular andre within the molecule alva. Phenol it is not having any intramolecular hydrogen bonding. Next, orthonitrophenol. This is having the intramolecular hydrogen bonding. No. Orthonitrophenol. Now this is the orthonitrophenol and it is having the hydrogen is attached with the more electronegative atom andre this is having the partial positive. Oxygen ಮತ್ತೆ nitrogen ಅಲ್ಲಿ oxygen is a more electronegativity alva andre adugoskara this is having the partial negative character. Now these two are forming the bonding that we call it as a internuclear hydrogen, paranitrophenol. Now this is a paranitrophenol. Clear? Now there is no any intramolecular nitrogen. Now paracrystal also it is not having. Next, the state of hybrid orbitals of the carbon CO2, CH4, CO3 minus 2. Now CO. Now hybridization is sp. 2 sigma bonds. Number of sigma bonds. If the number of sigma bonds plus 0 lone pairs alva, hybridization number 2 sp. Now CH4. CH4. Number of sigma bonds are 4. Andre this is sp3. Now CO3 minus 2 carbonate ion. Clear? Now here number of sigma bonds are 1, 2, 3. 1, 2, 3. Clear? Now these are not the lone pairs. Clear? Now this is having the sp2. No, sp3, sp2, sp3, sp2, sp3, sp3, sp2. Clear? Now this is the answer. Next, which of the following possess the net dipole moment? Among the following, which one will possess the net dipole moment? Now, SO2. No. Now, this is the structure of the SO2 alva. Now this is the dipole moment will be towards the more electronegative, and this is having. So this is having some net dipole moment. Now BF3. Now the net dipole moment, all the hybridized molecule, ಒಂದು ನೆನಪಿಟ್ಕೊಳ್ಳೋಣ ಏನಂದ್ರೆ all the hybridized orbitals, all the hybridized molecule PCl5, BF3, next CH4, clear? CH4, next what? BF3, PCl5, SF6, all are having the zero dipole moment. All the hybridized molecule without lone pair, all the hybridized molecules without lone pair is having the zero dipole moment. Clear? Now this is having the zero dipole moment. Now this dipole moment will be cancelled out like this. Now BCl2 is also, now its dipole moment will be cancelled out like this. Clear? Next CO2. Now CO2 is also hybridized molecule without any lone pairs. Now this is having net dipole moment. Next, now which of the following possess net dipole moment? Same question alva. Oh, next, which of the following pairs contain 2 lone pairs of electrons on the central atom? 2 lone pairs on the central atom ಅಂತ ಕೇಳ್ತಾ ಇದ್ರಲ್ವಾ, ಇಲ್ಲಿ ನೋಡಿ I3 plus ಅಂದ್ರೆ ಒಂದು iodine central atom ಇಂದ ತಗೊಳ್ರಿ, next 2 iodines as a bond, I3 plus ಅಂದ್ರೆ what? Now 7 electrons ಇಂದ I3 plus. Now take one iodine as a central atom. ಒಂದು iodine ಗೆ ಎಷ್ಟು ವ್ಯಾಲೆನ್ಸಿ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇರುತ್ತೆ? 7 ವ್ಯಾಲೆನ್ಸಿ. 1 ಅಂದ್ರೆ 1 electron has been lost. Clear? Now remaining 2 iodines. So this is S, this is P, now this is P, now this is also P. Clear? Now it is having the 2 lone pairs. Now 2 lone pairs. Clear? Now this is having the 2 lone pairs. This is having the central iodine, it is having the 2 lone pairs. Now O2, H2O is also having the 2 lone pairs like this. 2 lone pairs. How? 1, 2, 3, 4, 5, 6. Valence electrons of oxygens are 6. Hydrogen will form 1 hydrogen, 2 hydrogen. Now this is S, this is P. Now this two is having the 2 lone pair. Clear? Now both are having the 2 lone pair. Now idralli H2O, NF3. H2O, NH3. H2O already we know 2. NF3, nitrogen valence electrons is to 5. 1 fluorine, 2 fluorine, 3 fluorine, but only 1 valency, 1 lone pair. This is not having. XeF4. Xenon ge valence electrons is to 8. Fluorine. Clear? Now 2. It is having 2, but NH3, ammonia, 1, 2, 3, 4, 5. 1, 2, 3 hydrogens. Now 1 lone pair, but 2 and this is 1. SF4 minus 2. ಸಲ್ಫರ್ ವ್ಯಾಲೆನ್ಸಿ ಎಷ್ಟು? ಸಲ್ಫರ್ ವ್ಯಾಲೆನ್ಸಿ ಎಷ್ಟು? 6 ಅಲ್ವಾ? -2 ಅಂದ್ರೆ 2 electrons has been added ಅಂದ್ರೆ 8. Now oxygen will form the bivalent, not the monovalent. So 4 oxygens andre 4 double bond. Now there is 0 lone pair. This is 0 lone pair. H2S is also H2S. Sulfur valency electrons is to 6. Now 2 hydrogens. Now idralli 2 lone pairs. Now sulfur is having the 2 lone pairs. Now SF4 it is having the 0, but this is having the 2. Clear? Next. Formal charge on the central oxygen atom of the ozone. Central oxygen of the ozone. Now this is the oxygen. Now this is the oxygen. What is that? Oxygen. This is the Lewis dot structure of the O2. This is the Lewis dot structure of the O2. Now ozone andre O3 alva. Now innondu oxygen has been came contact with this O2. Innondu oxygen has been came contact with the O2. Now when this oxygen has been came the contact with this O2, now this electron ee oxygen ge but this oxygen, these 2 oxygens octet has been completed. But ಈಗ ಈ oxygen ಗೆ octet complete ಮಾಡೋಕೆ ಎಷ್ಟು electron ಬೇಕು? 2 electron ಬೇಕಲ್ವಾ? To complete this oxygen's octet also, this oxygen has been given this valency electron to this oxygen. Now ಈಗ in the form of a coordinate covalent bond. In the form of the coordinate covalent bond. ಈಗ in the form of the coordinate covalent bond ಇಂದ ಈಗ ಈ 2 electron has been shared between these two. This valency electron of this oxygen has been sharing between these two. Clear aitalva? Now that bond we call it as a coordinate covalent bond. Andre we will represent with this in this manner. Andre ಈಗ this oxygen electron has been given to this oxygen alva. Andre this oxygen has been lost the electrons. Andre this is having the formal charge +1. Now this has gained the electrons alva. No, it is gained the electron alva. Formal charge -1. Now this is neutral. This is neutral. Nothing gained, nothing lost. Its formal charge is 0. Clear? Now central atom formal charge +1. Central atom formal charge +1. Direct we can cancel it. Next, the percentage S character in the hybridized orbital of the nitrogen NO+2, NO3- and the NH4+. Clear? Now percentage S character. Percentage S character ಹೆಂಗ್ ಫೈಂಡ್ ಮಾಡಬಹುದು? Now first find out the hybridization, then percentage S character. Now percentage S character for the sp. Now this is sp3 already we have taken. Now sp3 hybridization percentage S character is to 25%. Clear? Now this hybridization is to nitrogen 1, 2, 3, 4, 5 valency plus andre one electron has been lost. Now this is sp, this is sp. Sp percentage S character 50%. Now this is NO3-, nitrogen valency electrons is to 5 minus andre innondu added. Now oxygen will form the double bond alva. Andre this is sp2. sp2 percentage S character is to 33.3. NO2 50, NO3- 33.5. Option number B. Clear? By this we have finished our important questions of our chemical bonding. I hope it is helpful for you. Illinda iga nanu tricks kodidinalva, aa tricks na ನೀವು ನೆನಪಿಟ್ಟುಕೊಂಡು ಅಂದ್ರೆ you can solve the chemical bonding questions very fast. Okay, will bye. See you with the another KCET Super 30 questions.